for sure. First, we're gonna start with probability. Okay. And within probability, you have something called theoretical and experimental. And I'm not going to go into more detail, but just so you know, probability is theoretical, what should happen. Experimental is based on what actually did happen. And then we're going to talk odds. What are odds? And I might come back to this page later on. Then we'll talk about using counting methods. For either coming up with a probability or coming up with the odds. That's going to be my next one. Then we're going to be looking at mutually exclusive events. I will say or not. Right, there are certain instances where it's not mutually exclusive. Basically, we'll focus on do not double count. Do not double count. That's what mutually exclusive is all about. Then we're going to talk about conditional probability. Probability, and it kind of says it all right there. There's a condition, right? And I'll say that first event affects second event. So that's when what happens first does change what happens next. And so I'm going to give you a quick example. If you're drawing cards from a deck of cards and you don't put it back, right? If you draw one and I walk around and I ask someone else to grab another one, the first event has affected. Right now you had 52 cards, you were down to 51 now. So every time something happens, it changes the probability. I think that's it for now. We'll just leave it at that. So these are some of the main points that this unit is going to cover. And today it's going to be somewhat of a review. I don't know how much probability you did in grade 9. I'm not sure. We'll see. We'll catch you up with some of those things. Okay. All right. Let's dive in. So we're going to go straight to page 3. And so there, I'm just going to, probability is the likelihood of an event happening, and it can be stated in 4 ways. It's going to come back later. So for now, we're just going to keep it that way. So in 4 ways. So fraction, decimal, percentage, words. Okay. So this is something I need you to understand. When you see a fraction and I ask you state it as a decimal or state it as a percentage, or what we do is we first look at our calculator. Like when we divide 1 divided by 3, I think everybody knows what that's going to be, right? 1 divided by 3 is just 0.333. Just write down a bunch of 3's, and the assumption is that continues. So this is kind of like my calculator screen. Right, so that's what you're looking at your calculator, and so from there you answer the other ones. So if it asks you to state it as a decimal, you would state it, if you wanted to round it to 2 decimals, you would state it like that. If you wanted to state it as a percentage, if you were to say 33%, you would be wrong. Like you would lose half a mark for rounding because you base it on this answer, correct? If you do that, you got to go back to your screen and basically multiply that by 100. Multiply whatever you see on your screen by 100. And then you would now say it's actually 33.33% if you wanted to round it to 2 decimals. And in words, the easiest way is I just read out the fraction. 1 out of 3. Okay. 3/4, the same thing. 3/4 is a lot easier because it is finite, right? We call that a finite decimal. So if this is your screen, you would say, well, as a decimal, guess what? It is just 0.75. As a percentage, if I go back to the original, it is just 75%. And this would be 3 out of 4, okay? Not going to park very long there, but I thought it's worth reviewing. Probability of an event happening, often I call it PA. And the probability of something not happening, P not A, remember that, or the bar across, is always 100% or 1, right? That you got to understand. Therefore, if there's a 4 out of 5 chance of it raining, we know that there's a 1 out of 5 chance of it not raining. Okay, so probability of rain would be that. Probability of not raining would be 1 over 5. If you were to add this, watch, I'm going to add the plus sign here. If you go this plus that, we get 5 out of 5, which is 1. Or we could state that as a percentage, which would be 1%. If the probability of rain is 0.8, then the probability of it not raining, watch, I forgot the not, right? So I'm going to put the bar on top, is 0.2, which is 1 or 100%. So regardless of how probability is presented to you, you still know that they add up to 100%. So 80% chance of rain. Therefore, if we were to add probability of it not raining, which we know is 20%, that just adds up to 100%. And so remember that is a very important concept to us. Very, very important. It's going to come back later. So in general, probability of an event occurring is number of favorable outcomes. And some students find this hard to wrap their head around. What does that mean, number of favorable outcomes? Number of events you are after. How's that? I don't know, I'm just going to try that. Number of events you're after. So if drawing an ace is what you're after, right? If hey, I want to know a probability of drawing an ace, then that's what number of favorable outcomes would be. How many aces in a deck? 4, right? So 4, and then total is just obviously all possible answers. And I want you to highlight this box, but I'm going to use a different color for the total part. That is very important for probability, that at the bottom you have all possible outcomes. Okay. An event is a collection of favorable outcomes that satisfy a specific condition. The sample space or universal set, let's highlight that one. We talked about the universal set before. It's also known as the sample space, okay? Is the total possible outcomes of an event, both favorable and not favorable, okay? So the total includes everything. The complement of an event is denoted as, I think you already know that, but here it is again. Complement is written like that. And it represents outcomes that do not satisfy the condition, but are part of the sample space nonetheless, okay? So if maybe highlight the little apostrophe there. Okay, so this would be, and don't fixate too much on notation. Later on, you'll see how we do this, right? The probability of, let's say, Mr. Erickson calling in sick. Let's say you're after that, right? So that's what A represents. So that would be number of instances Mr. Erickson calls in sick over total possible days that there are in a semester, right? That's what, and then this would be Mr. Erickson not calling in sick. How often is he not sick? And a universal. So these are the same. The universal stays the same, but what goes on top changes based on the scenario. Okay. Also, since PA and P not A, so calling in sick and not calling in sick would be 1 or 100%, we can also say from this that PA would be 1 minus P not A. Okay, I hope this makes sense. If not, it will make sense later. Okay, so you can also say P of not A would be 1 minus PA. You can add that. They're the same. They're derived. These two are derived from this concept right here. Okay. Oh, you can't see it. Was it not on the screen? Sorry, guys. Let's try this again. PA, right? And P not A. I don't know, using rain or, right, probability of the Jets winning and not winning is 100%, right? And so therefore, if you wanted to know the probability of the Jets winning, you would go 100% minus them not winning. Alternatively, if you wanted to know the probability of them not winning, you could just go 1 minus whatever the probability of them winning had been determined to be, right? So both of these are. Sometimes you wonder, like, why go through the trouble of mentioning this? It's because sometimes you're gonna have to go this way, right? You're gonna be stuck with having to think of those two. Okay. Note, if a question asks for the probability of an event occurring, you should immediately try to come up with a fraction, okay, where the denominator is greater than the numerator. This is very important. Sometimes students, because they're not able to find the universal, they just slap anything in the denominator. And if the denominator is smaller than the numerator, you're in trouble. In probability, we cannot have that. When it comes to your bank account, growth in bank account, growth in population, you can have more than 100%. But you cannot have that when it comes to probability. It's 100% is all we have, no more, okay? A fair game has a probability of winning a 50%. If something were to be considered zero chance, it is impossible, where 100% is definitely certain. So these are, right, like there's your 0, your 100, so impossible, certain. 50 would be a fair game, which is not the case in when you go gambling, okay? It's not 50. You don't do that, it's rigged, okay? Go page 4 here. I'm just going to briefly touch on this. This isn't going to show up all that often, but you need to understand the difference. There's something we call experimental probability, EP, and let me highlight the important thing about experimental. It is based on trials or experiments. That's the difference between experimental versus theoretical. It is based on possible outcomes. You can, to help you out, do I have that in the notes here? I don't. So this is what I'll ask you to add that here. Should happen. This is what should happen in theory. And this is what actually happened. So for example, probability of rolling a 6 is 1 out of 6, right? Everybody knows that in theory, that's what should happen. But it could be that you roll it a couple times, and in your experiment, it doesn't amount to 1 out of 6, right? And the reason why is you need to keep rolling more times. Like if you only roll 10, 15 times, it's not accurate enough. You got to go 100 or a couple hundred or maybe 1,000 times for the theoretical to match your experimental. So sometimes they're different, and that's mainly due to the sample space. So can I just add this part here? You will notice that the main difference is the bottom here, NT and U. Okay, so the NT here is the number of trials or experiments, okay, versus the NU is the total number of possible outcomes. So this is possible, this is number of trials. Okay, like just if I ask you what the difference is, that's what it is. Okay. In general, when we perform experiments involving events where there's no bias, the experimental probability should be similar or equal to the theoretical probability. The main reason they may be different is because there's a small sample space. Okay, and I will rephrase this: low number of trials. Low number of trials. That is the culprit for them not being the same. And then there are certain cases where you can just not use theoretical probability, like blood type. Okay, you can't say how many blood types are there. Like anybody? 5, 6, 7, 8, 8? I think. Okay, let's go with 8. You can't say that it's 1 out of 8. Like there's 1 out of 8 chances of you having a certain blood type. It's not true. We all know that there's one type that is way more prevalent than the other. So there you just wouldn't use theoretical probability. You would base it on trials, right? But rolling dice, cards, anything like that, you would actually base your decisions on theoretical. You would not care about the experimental, okay? Oh, I just drew an ace last time. My chances of drawing an ace now are better. It's like, no, they're not. Still 1 out of 4 out of 52, right? So keep that in mind. I'm going to move on because you're probably going to roll your eyes if I keep going. But maybe one more thing down here. Theoretical probability should be similar, if not equal, to experimental probability if sample size is large enough. So that's something probably that summarizes this slide right here. Okay, I'm going to give you a little bit of time, but not to finish the whole page. If you go to page 5 here, I'll do a couple with you to start you off, and then I'll see how well you do. Always remember, probability can be stated in 4 ways. Okay, always remember that. So state the probability of the following as a percentage when rolling a 6-sided die. So total outcomes, total possible is what? 6, yeah. Keep in mind, I do have questions with 12-sided die or whatever, so keep that in mind. 6 outcomes, okay? So that's something, in this case, that we know. It's like, hey, this is the total possible. So probability of rolling a 2 would be 1 out of 6. I wouldn't mind. Can you do decimal and percent as well? Just a good practice. So if you go get that into a decimal, I'll just show you on the calculator, because it's the nuance of getting this right. If they asked you as a decimal, you would go, watch this. I'll show you a little trick here. You will not be docked marks if you provide more than 2 decimals in your answer. The only exception is money. They're very picky with money, 2 decimals every single time. Everything else, if you do more than 2, is fine. So what I tell students often is like, hey, just round this to 4 decimals, and then you can use this answer to write out your percentage, right? You just shift over the decimal 2 spots and then bingo, right? That's another way of answering if you want to do it that way. 4 is okay. 2 is minimum. 3 is good. 4 is good. 5, right? So you gotta just make sure you do this right. Probability of even. How many even numbers? There are 3 out of 6. That'd be 1/2. I think we would all know that's 0.5, which is 50%. How about, can I ask you to try the other ones? You need to know your primes again. Let's write prime up top here. Primes would be 1, 2, 3, 5, 7, 11, 13, 17. That's good enough for now. Thank you. It's numbers that are only divisible by 1 and themselves. Okay. So I'm going to start going over it. Probability of a number divisible by 3, it would only be 3 and 6, right? So you can actually go 3, 6. So it's just 2 out of 6, which is 1/3, which is 0.3333, which is 33.33%. Prime. Wait a minute. Sorry, guys. 1 is not a prime. So that'll change your answer, but we need to fix it. It starts with 2. I don't know why. Change that up top here too, in case you add it to your study sheet. I don't want you to get that wrong. It starts with 2. 1 is not in there for some reason, even though by definition it's whatever is divided by itself and 1. So, but 1 isn't in there. So it starts with 2 and 3. So sorry guys, so that'd be 2, 3, 5, right? So that's 3 over 6. That'd be 1/2, 0.5, 50%. Less than 5. Less than 5 means, right, 1, 2, 3, 4. So it's 4 out of 6, which is 2/3. That'd be 0.6667 or 66.67%. Greater than 6, 0, right? There's no number greater than 6 in a standard die. Greater or equal to 3, so 3, 4, 5, 6. So that'd be 4 out of 6 as well. I'm just going to go 2/3 there and leave it at that. So that's a die. Okay, given a standard deck of cards, it's a probability of grabbing an ace, 4 out of 52. That'd be 1 out of 13. Yeah. So I'll write this down as a decimal and then 7.69%. Did I show you how to simplify a fraction on your calculator in grade 11? I'm not sure if I did, because if I ever ask you, all you do is this, 4 divided by 52 like that, and then you just press math and hit enter, and it will reduce it for you. Because we're gonna have huge numbers later on, like, right? And so it's nice to just reduce it to something like that. And that's why I'm not going to give marks for reducing. Whether you reduce or not, I'm not going to give marks because you have your calculator to do so. Okay, you just need to know how to do it. If it can't, if you type in your number and it gives you the exact same fraction, it just can't, right? So keep that in mind. Probability of drawing a club. There are 13 clubs out of 52. That's a quarter. Just think of it as, right, it's a whole suit, 1 out of 4. So it's 0.25 or 25%. Ace of club. So out of the club suit, there's only one ace. And that's a very small number. That's 0.0192. That's 1.92%. So I'm gonna, greater than 6, what does that mean? Greater than 6. So I guess you would say it would be 7, 8, 9, 10, Jack, Queen, King. Okay, so 1, 2, 3, 4, 5, 6, 7 per suit, right? So you got to go this times 4 basically. It's 28 cards. All right, so that'd be 28 out of 52. So that's 7 out of 13. That is 0.53. Yeah, I know. I should have probably clarified. Red Queen. I have to think of 2, right? 2 red queens out of 52. That's 1 out of 26. That is 0.0385. That's 3.85%. Probability of red, that's 26 out of 52. That would be 1/2, 0.5, 50%. Not face card. Here's where I want you to pay attention. It is going to be out of 52. And that's the total possible. Not face, I go like this. I go 52 minus, this is the indirect reasoning. I'm going to take away the 12 face cards from it. And so I'm left with 40 out of 52. Okay. And that's, if you want to reduce, oftentimes I just slice it in half if they're both even. So it's 20 out of 26, 10 out of 13, until I run out. If you have a prime somewhere, then you're basically done, right? That's 0.7692, which is 76.92%. So this is not drawing a face card. If you think about it, there are more non-face cards than there are face cards. So that's where this answer does make sense, right? Probability of picking a jack, 4 out of 52. I believe we have a 4 out of 52 way up here, so I'm just going to use that to help me out. And then not picking a jack, right? That would be what? If you take my approach, I would say 52, take away 4. That's 48 out of 52. Okay. And that reduces to, you want to use you can use this, right? 48 divided by 52, math, enter, 12 out of 13 reduced. All that power that this calculator has, eh? Sweet. 12, 13. That is 0.9231. That's 92.31% of not picking. And what do these add up to, guys? Picking jack, not picking jack. 100%, right? If you add that up, you would get 100%. 100%. That's where this comes back in, right? Something happening and not happening adds up. Sorry. I need to work on my camera skills here. That's where this comes in again, right? To maybe I'll do that right here. You know what would have been a lot easier than what we did here is probably probability of not picking a jack. I'm just going to show you another way of doing this exact same thing would be 100% minus probability of picking a jack. Okay? So you would go 100 minus the 7.69 that we've already calculated, and that's 92.31%. Okay, so I just wanted to keep this in mind, right? If you've already done something, it's like, oh, I know what it is. So what is the probability of it not happening? Well, just take it away from 100. Whatever remains is it, right? Probability of a red face card. There are 12 face cards, right? And 6 of them are not are red. Okay, 6 of them. That's 3 out of 26. That would be 0.1154. It's hard to come up with questions that don't have repeating answers from the previous, from whatever you did before. So I think most of these are different final answers. So I hope you had fun with this. It's a good review. Deck of cards are quite popular, so make sure you have your study sheet beefed up on that one. Okay, I thought I would just quickly remind you, refresh your memory on this. I'll do it right. You know what? There was a blank page just after the cover page. I promised I was going to do it in chapter 3, and I didn't do it. So I feel bad. Okay, so there's natural numbers. That would be 1, 2, 3, ... right? That's just make a circle. This is on page 2 that I'm doing this. And then you have something that wraps around that is what we call whole numbers. Whole numbers would be 0, 1, 2, 3, ... So it includes the 0. That's the difference there. And then something that surrounds that would be called integers. And integers just include the negative whole numbers. So it'd be -2, -1, 0, 1, 2. And so it's ... from either end. Right? So you go negative in each direction. So those will be your integers. So if you can make a small version of this, and then maybe I'll just add prime here as well. Prime doesn't really fit. I guess prime would fit. It could fit into natural numbers, but I find that I'm just going to give it a separate category here. So prime divisible by 1 and itself. That's what prime is. So here are the first couple. So if you wanted to state it as a set like this, be 2, 3, 5, 7, 11, 13, 17, 19, and that list keeps going like that. But if you know the first couple, you're in good shape. And if you know what it is, okay. Somebody missed the diagram. Sorry, there it is. One more time. So you've got your naturals, your whole numbers that include 0, and then you've got your integers, which goes to negatives as well. Okay. So here it is. Only 3 chapters later, finally you know your numbers again, right? Okay, let's do odds now. Page 6. So today is just like reviewing probability and odds basically. Odds, when we deal with odds, it is important to remember there's no universal or total given, okay? Don't forget that. Probability does, odds do not, okay? When stating odds, we use the colon, right, where we compare favorable to unfavorable events, okay? Or you can say event happening, not happening. So I'm gonna rephrase the exact same idea multiple times so you can wrap your head around this. So for odds, there are two instances that you need to consider. There is in favor. So whenever it says in favor, it's actually gonna tell you what the format is. So in favor and odds against. So when you those words mean something, it tells you the order in which you're going to place those numbers. Okay. So, guys, all of these are saying the exact same thing. Okay, so don't be like, which one, which one? They're all saying the same thing. So you can either think of, if it says odds in favor of Mr. Dirksen calling in sick, it'd be how many times does he call in sick? How many times does he not call in sick? Right? For against, it'd be the same thing. NA, right, that's just in letter notation or using the proper notation. Number of instances where Mr. Dirksen does call in sick. Number of instances he doesn't call in sick. I forgot the N here. Not that it doesn't make a big difference, but technically it should be. Number of instances. This goes back to chapter 3, right, where we use NA, right? If you've seen it, that's just number of instances. Odds against, watch this, you just flip it. Right? To go from one to the other, we flip the order, right? You saw non-favorable here. So if somebody asks you what are the odds against Mr. Dirksen calling in sick, the against tells you're going to put the times I do not call in sick, and then this will be the times I do call in sick. It's just flipped. So quite often the province gives you odds, and it says, what are the odds against it happening? Really, all you need to do is flip it. It doesn't happen very often, but sometimes you get a freebie like that, okay? So that's all you have to know. Remember to reduce all fractions and ratios. You know what? I'm not too picky on that because the province doesn't. We don't take any marks off for not reducing. So I'm not going to do either, okay? I do think it's important. It's an important skill. So I will probably on my keys and when I do work, I will show you how to do it. Use your calculator if you need to, okay? To get rid of the total, to get the total, the sample space, the universal, these are all the same. This is probably a good one to highlight. We add NA and N not A. Okay, so I'll give it a different color. Like this, I'll just circle it. Maybe I'll just do it one more time here. Total is NA and not A. Same thing. Where are these NAs coming from and not A? It's coming right from your odds. So if you add these two numbers together, that's the total number of instances we're considering. Jets winning, not winning. Like let's say you wanted the odds in favor of Jets winning. Let's say it's 5 and 2. So that we're considering 7 games. If it's 5 and 2, then it'd be 7 games that we're considering in total, okay? Remember that. And we'll practice that, then I think it's going to make more sense. And you're probably not going to really care about the notation all that much because you're going to just understand what's happening. Converting odds to probability. So I'm going from odds to probability here. So if you have the odds for, we know it's going to be in favor and against. That's how the numbers are going to be in that order. So watch this carefully. If I gave you these odds, these are going to be numbers, and I said, hey, state the probability of A happening. Mr. Dirksen calling in sick, whatever you want to say, right? Then probability of Mr. Dirksen calling in sick, I take the favorable outcomes, I put it at the top, and then I take both numbers, I add it up to get my total. You see that? These two added together is the denominator here. If I asked you probability of not calling in sick, you would take this number, put it up here. This number goes up here. Watch this. You still always add the numbers together to get your total. Always. Okay. This is the same. Maybe I will highlight that part. I like you to know that this is a must for both of them. This gives you the total. Okay. This gives you the total. That's how you get your total. Just add up the numbers, whatever they are, just add them up. That's your total for your probability. So let's do an example here. The odds of the Jets winning the Stanley Cup is 1 to 6,000, right? So not very good. While the Avalanche's odds against winning are 400 to 3. Who has a better chance of winning? Show your work. I would say convert both to probability. You have to do that. If you just look at the odds, you're not going to be able to accurately answer that. Okay. So let's talk about Jets. We're going to copy down that number. The odds, right? Like this. What are these odds? It says, I'm going to write it next to it, odds of winning. I'm going to zoom into that for now because this is very important. Let's write the Avalanche odds right next to it. This is Avalanche. I'm not a hockey expert, so if the odds are off, I just made it up. Okay. What does it say here? Odds of what? Is it of or against? It says against. Win. Okay. I'm gonna just make sure you understand that this is in favor. Odds of, these are odds against. It means something to us. Sorry guys, write that down. And let's write down the odds the way they have before. And once you're ready, here we go. If it says odds of whatever this is, it's winning in this case. That means that this is win and this is not win. Or you can also say losing if you want to, but I'm going to go with a not, okay? If it says odds against win, where is the win in this case? It's actually going to be here. And the not win is in front. So that's how we came up with this. That's how we came up with the order. We now know what each number represents because we read the odds. What did it say? Did it say off or against? Okay. So probability of winning. Which number are we going to grab at the top? Obviously the 1. Okay. Boom. There it is. What are we going to do at the bottom? Please just know you just add those numbers up. That would be 1 over 6,001. That's your probability of winning for the Jets. Now let's look at Avalanche. Probability for them to win. let's do the easy part. Let's do the easy part first. We're going to add these up, correct? Let's do that. I like to do the easy part first. So, okay, got it. Now I need to pick one of these numbers. And I've determined that the number of instances them winning is the 3, based on the wording. So I put 3 up here. So this is 3 over 403. Yeah. Because right now we're interested in finding the probability of winning for both of them. And because it stated it as odds against winning, when it says against, then the first number represents it not happening, not winning, and the second number represents winning.
In the formula, it says not winning at the top. It says not winning.
This one here?
Yeah.
So if we had wanted to find the probability of not winning, then we would have stated this one. Then we would have, but we are interested in the probability of winning right now. Good questions. I did this on purpose. I messed it all up on purpose so that we have to like think, right? So can we tell at this point who has the higher probability? I would argue still not. I will get it into a decimal or a percentage, and then I'm going to make my final conclusion. So here we go. You take your calculator. You're going to go 1 divided by 6,001. I'm going to multiply that by 100. This is 0.0, and you use more decimals if you have to. I'm going to go 17. This is already percent. This is already percent. I multiplied this by 100. Whatever I got when I divided, I multiplied it by 100. And now we're going to go to avalanche. That's 3 divided by 403 times 100. That's 0.744. I'm going to use 3 decimals as well because I did with the other one. Percentage. So now you can tell the avalanche have a higher percentage of win. Okay? Greater chance of winning. So what did we do here? 2 things. We learned how to convert odds to probability, and we also learned that we can use the probabilities to compare which one is more likely to happen. Okay, so I did 2 things here in this question. So just watch for of or against, because that tells you where the event is going to go. Okay, let's try next page here. Now we're going to go the other way, from probability to odds. Whoa, right? What is this? I don't like this, right? Just follow me here. Converting probability to odds, and I probably will give you a cleaner version later on, but we need to understand what's happening. So probability to odds. So if you have probability of, let's say, raining, probability of raining is something over something, then the odds for the event happening, odds for, okay, would be you put that number here, and on the other side, watch what's going to happen. On the other side, cover this for a little bit. We want the number of events of it not happening. That's what we want on this side. And the way we find it is we take our universal and we subtract the events from it, from the universal, to get us the NA, the A naught. Okay. Similarly, if you wanted the odds against A happening, I would basically say you start with NA, you go NU minus NA, so you subtract these 2, and then you compare it to NA on the other side. And let's let's just put it this way. You're going to have to practice this to get familiar with it, and then you're probably not even going to care about this notation anymore once you understand what needs to happen, okay? But just remember, you have, if it's 4, then the event comes first, and it not happening comes second. If it's odds against, not happening comes first, then it happening comes next, okay? So that's kind of like the pattern here. So let's try this. I have to hurry. Okay. Example here. The Bombers have a 45% chance of winning the Grey Cup. I think it's higher now. When I made this, it was probably before they were doing so good. While the Edmonton Elks have a 7 out of 9 chance of not winning the Cup. Write both probabilities as odds for and against winning. So let's do Bombers first. Okay. Let's focus on Bombers first here. So the probability of them winning is 45%. And I like to turn that into a fraction if at all possible. How can we turn a percentage into a fraction? You just go 45 over 100. Think of the percent symbol as the 2 zeros you're adding underneath. Right? Percent. So I like it that way. So if it's odds in favor of winning, then that means that I would want to go like this. Win, not win. Right? If that's what they're asking me to state, then that's how I would write it. Okay. So I would go 45. Right? I grab this number, I put it down. And then on the other side, I will go 100 minus 45. Okay. This would be 45 to 55. Can you reduce that? 5 goes into both of them, right? 5 goes in here 9 times. 5 goes in there 11 times. That would be the reduced. Those will be the odds of them winning. I'm going to do the next one. Odds against win. I put this on the side here. Cross that off. Odds against winning. Well, if it says against, then I want the not winning part to be up front and the winning part to be next. Since I already did the work, I'm just going to take this, right? If you have the odds in favor, you just flip the numbers and voila, you're done. But you could have gone back to this if you had wanted to. Let's do that just for this exercise. I'm going to say this is 45 and this is 100 minus 45. So that'd be 55 to 45. You can reduce that. That's 11 to 9. You can tell they're just flipped versions of each other. So there's not just one way of doing this. Fun stuff, eh? Practice. Elks. What are we given? Probability of not winning. Do you notice that? I will highlight the not. Right? Not winning the cup. It's the wording is key. Is 7 over 9. 9 is my total, right? Remember, probability always has total. So odds in favor or of, it doesn't matter. I will have to be careful here. It means that I want the win here and not winning on the other side like that. Let me ask you, can I put the 7 in here? Can I just put it in the win? The answer is no, because it's probability of not winning. So this, if you want to look at it that way, that's A, that's not A right there. This is like it not happening. So that 7 actually comes here. And then over on this side, it's 9 minus 7. So that'd be 2 to 7. That's already reduced. Odds against, you have two options at this point. You can just flip this one, or we can say, well, odds against means not winning, then winning. Guys, they won't always be about winning, right? Sometimes it will be rain, sometimes it will be, you name it, right? But I could, in this case, just grab the 7, put it up front, and then winning would mean I would just have to go 9 minus 7, right? This would be 7 to 2. And you see it's the flipped version of the first one. So regardless of how you do it, you come up with the same answer. And guess what? You can always check, did I do this right? What do we always do with these two numbers to come up with the denominator? We add them, right? If you cannot do that, you made a mistake, right? If these numbers do not add up to this, same here. 9 and 11 is 100, right? Doesn't work. But then you just got to add these two here. 45 and 55 is 100, right? So this wasn't a reduced fraction. We could technically have reduced this. 5 goes in there 9 times, goes in there 20 times, sorry. So now the 9 and 11, the reduced part adds up to 20. Okay, so I'm going to ask you to try pages 7 and 8, whatever remains. How's that? Okay. Page 7 to 8. Not that much, but just to get you warmed up. Did you have a question? You had a question? I think in this case I didn't ask, but you would just, in this case, you wouldn't need to do the odds. You would just turn both of these into like a decimal percentage, and then that's the best way to answer. Odds don't really help you there. Thank you, guys. See you.